hospital where I was the director of food and nutrition services. And then since moving to Portland, I've started my own practice. I primarily work in the space of gut health, working with primarily women. I do see a few men in my practice. Most of them are partners of the women that I see. And like I said, I'm just so sad that I'm not up there. I was planning to be there with all of you, but my husband just started a new job where he's going to be in the middle of the Pacific Ocean for about 3 months at a time working on this platform, and his departure just happened to coincide with just being right before this presentation. So here I am presenting virtually, but I'm with you all in spirit, and I'm really excited to present today on one of my favorite topics, which is the gut-brain axis. And so, in my opinion, arguably this is one of the most fascinating parts of human physiology. This gut-brain axis is a bidirectional communication highway between our gut and our brain. Our brain and our gut is constantly communicating back and forth all day long, and we're going to be delving into this throughout our time together today. We can't move too far into this presentation without talking about the microbiome. And I know most of the people that are listening to this are dietitians. You're probably all very familiar with what the microbiome is, but just in case, I just want to make sure that we're all on the same page with what some of the terminology is that I'm going to be using today. So contained within the gut is an abundance of beneficial microbes that comprise the gut microbiota, or microbiome. There's approximately 6 pounds of bacteria that live in the large intestine. And, just again, for clarification of vocabulary, the microbiota refers to the actual bacteria versus the microbiome, which are the bacteria as well as the genes that they make. These bacteria actually have a large amount of DNA, and there's some studies that tell us that we actually have 150 times more microbial DNA than in our body than human DNA. I've actually listened to a few researchers recently who are starting to refute some of that, but we're still just going to say that because we've been kind of saying that forever. So all in all, this is about 2.5 million microbes that live within our gut. And so what we're learning about the microbiome, and we know this through a lot of the research that's being done around the gut-brain axis, is really these microbes are in charge. They command so much in terms of our health, in terms of our immune system, in terms of our mood, our emotions, our cognitive function. These really are command central for everything that's happening in our body. And if we don't have the right microbes, it will alter our functionality dramatically. So our microbiota is determined very early on in our lives and is primarily influenced by how we were born. So if you were born via C-section versus vaginally, you have a very different microbial makeup. And the reason for this is that during a vaginal birth, as we're passing through the canal, we pick up lactobacillus bacteria. Additionally, right after we're born, the people that we come into contact with, the people that handle us, also really influence what the microbial makeup of our gut is. So depending on who the nurses were, who the doctors were, who the family members were, let's hope that they all had good gut health and a good microbiota, because in those early moments in our lives, it can absolutely influence what happens with our own microbiota. So throughout our life cycle, the microbiome really starts to change. So in that state of infancy, it's really kind of haphazard, but by the age of 3, it starts to resemble that of the adult flora. And there's some studies that even show that what our microbiota looks like by the age of 3 is kind of predominating factor or predominating picture of what our microbiome looks like throughout our life. But of course, there's a lot of factors that can also influence this. One of them is actually just aging itself. So we start to see a natural decrease in both abundance and diversity as we age. And depending on how this is happening or the rate that this is happening, it's one of the factors that significantly contributes to aging. Other factors include things like diet. And of course, we're going to talk some about that today. I'm actually not going to delve into the impact of nutrition on the microbiome too heavily today. But I think, just suffice to say that, that one of the strongest, determining factors in what our microbiome is what we eat. And, we see this in studies that have been done on people who immigrate into the United States and eat a traditional diet and then come into the United States and, who knows what they were eating, but something that resembles a standard American diet, how that has a dramatic impact on both abundance and diversity of the microbiome. And we also see this play out geographically in studies that are done in people who live in tribes in Africa or tribes in remote regions throughout the world, where people eat, whose diets are comprised of more fiber and more polyphenols, and how that supports abundance and diversity in the microbiome as opposed to a standard American diet. Pharmaceuticals also have a huge impact. We all know antibiotics being one of the biggest ones, but other really commonly prescribed pharmaceuticals include things like proton pump inhibitors, NSAIDs, even things like metformin, all influence diversity and abundance of the microbiome. And then things like exercise. So the myosines that are in the protein in our muscles actually influence the microbiota. So the more muscle we have, the more we exercise. Again, that contributes to both diversity and abundance. And finally, stress. And we're actually going to be talking about stress a fair amount today because there's a huge connection between stress and how that influences the gut-brain axis. Okay, so the first thing I want to just clarify is we're going to be using the word gut a lot throughout this presentation, and I just want to just make sure that when you hear that term, that the mental image in your brain is not only either your stomach or your small or large intestine, but that when we're talking about the gut, we are actually referring to the entire digestive tract from our mouth to our anus. So this whole 9-meter, almost 30-foot long tube. It's, our whole entire digestive tract is segmented by different sphincters, and each of the different sections of our digestive tract really does have a different microbial makeup, and different even abundance and diversity within each section. But every single part of our digestive tract has an impact on the gut-brain axis. And so this can be anything from the microbiome that is within our mouth. We know that, if there's a dysbiotic environment in the mouth, that has a tremendous impact on, the overall health of bacteria throughout our digestive tract, but also how that connects to our brain, and so on and so forth. So I just want to make sure that as we're talking about the gut, that we think about this in its totality, and that we're not just thinking about the gut in terms of the large bowel. But all of that said, I do want to point out that this is an example that shows us how the microbiome varies along the digestive tract. So within the stomach and the duodenum, the concentration of microbes is lower, and there just isn't as much diversity. And then as we move into the jejunum and the ileum, the pH becomes more neutral, the oxygen availability is lower, and this environment supports a greater density and concentration of microbes. And then as we move into the colon, this represents the most diverse and abundant population of the microbiome, because this is where transit time starts to slow down, and again, the pH is more supportive. So let's talk about the role of the microbiome. There's a lot of functions of the microbiome that influence so much of the physiology within our body and as well as disease. But I really want to keep this more, within the context of our conversation today, which is about the gut-brain axis. So here's just so there's a lot of roles. I'm just going to highlight a few of the key roles. And the first is metabolic function, and where the microbiome really influences metabolic function is through the digesting and fermenting of dietary fibers into short chain fatty acids, where this food is then these short chain fatty acids are then used as food for colonocytes. Also metabolically, the microbiome is involved in the production of certain vitamins. So vitamins K, there's B vitamins that it helps to produce. There's structural function, particularly as it influences things like the gut mucosal and the epithelial layer. So that kind of inner lining and outer lining of the gut is, strongly influenced by the health of the microbiome and how much, again, diversity and abundance we have versus how many maybe dysbiotic or even pathogenic bacteria reside within the gut. And then last is immune modulation. So, we again, I've heard kind of varying statistics about this, but that the majority of our immune system really does reside within the gut and is influenced by the microbiome. And I've heard as much as 80%. And read research that supports that. So the microbiome is, something that triggers the immune system within our gut, and this immune system is one of the key ways that our gut communicates with our brain. So I think most pertinent to this conversation is the role of the microbiome in brain function and the regulation of the gut-brain axis. So the gut microbiota has demonstrated unique functions that are associated with behavior, mood, and cognition. And one of the ways that the microbiota influences this is through the conversion of neurochemicals into neurotransmitters. So, and just, to clarify what neurotransmitters are, these are the chemical messengers that enable neurotransmission. So once these neurotransmitters are synthesized by the gut, specifically from amino acids, which is something I talk about really frequently with my patients, especially patients who have depression or anxiety, is that, we always talk about this connection between amino acids, eating enough protein, and the health of and the capability of our body to synthesize neurotransmitters. So once these neurotransmitters are synthesized, they then travel to the brain using this gut-brain axis. And again, all of these communications and connections are happening millions of times a second. And because they don't just travel one way, they're also impacting gut signaling in the brain. So the first one that I just want to point out, I'm again not going to spend a ton of time on each of these, but the first one is serotonin, because not only does serotonin impact mood, but I think important to note is that it modulates our immune system and also impacts inflammation. And this inflammation can, be both inflammation that's within the gut, but also systemically. Serotonin is also involved in the release of, or is released by the digestive tract and the spinal cord, and facilitates secretion in the gut as well as peristalsis. Dopamine, this is a catecholamine that is made and found in the central nervous system and is involved in the regulation of electrolyte absorption in the gut. It plays a role in the mucus production. And so when we see, again, patients who have neurological conditions that are associated with low dopamine production, oftentimes we'll see that there's a lot more inflammation in the gut. There's that reduced mucosal layer. Then they may have some symptoms and even disease states that are associated with that. And one of those can be things like ulcers, because that mucosal production that's within the stomach is also, in a way, regulated by dopamine. Next is norepinephrine and epinephrine, because of the major roles that they play in nutrient absorption. These also impact how the body, how the glucose concentrations within the body. In these decrease gut motility, they increase contraction of sphincters, and they inhibit secretions. And when we think about norepinephrine and epinephrine as being produced during the state of fight or flight, all of these things make sense, because in that state of fight or flight, our body is slowing down gut motility. It's actually reducing and inhibiting just the action of secretions in the gut, including reducing things like, the production of digestive enzymes and stomach acid, and is starting to shunt blood to the large muscle groups, to the heart, even to the brain, and increasing glucose concentration in order to get the body to be ready to run or to fight. So, to think about, a lot of this is actually occurring in the gut because of that signaling from the brain, and that, it's all designed to, essentially keep us alive. And then conversely to that, the last neurotransmitter that I just want to talk about that is also released from the central nervous system is GABA. And this is a neurotransmitter that supports relaxation. So in the digestive tract, it supports relaxation of the lower esophageal sphincter. And connected to, like, more systemically, what happens in people's bodies is GABA is really important for that state and that feeling of calm, and is also connected to things like the amount of deep sleep, somebody's ability to go to sleep and stay asleep and get that good deep sleep, where the lymphatic tissue in the brain can start removing toxins in the brain to help support cognition and memory and mood. So these are some of the examples of neurotransmitters that are produced in the gut. And I think, again, like, connecting this to the microbiota is that specifically these neurotransmitters are produced by those bacteria that are in the gut. And as you can see by this slide, the majority of them are produced by really common bacteria, like strains of Lactobacillus, Bifidobacterium, and Bacillus species. And some of these are the most abundant strains of probiotics and beneficial bacteria that are in the gut. So how does communication take place exactly? So this communication between the gut and the brain, it happens through kind of three different systems. One of them is our nervous system. The other is our hormonal and endocrine system. And the last is through immune signaling. And this is a slide that illustrates this, the number of pathways that are involved in this bidirectional communication between the gut and the brain. So how this communication works is that the microbes that live within our gut, down here, then comprise the microbiota, communicate with the central nervous system through neural pathways, which includes the central nervous system, the autonomic nervous system, and the enteric nervous system. And then in the immune and the endocrine pathways, primarily this is through the HPAT axis. which is the hypothalamic pituitary adrenal thyroid axis. And we'll talk about how the HPA axis impacts things like stress and cortisol, and how that even, starts to shift things like microbial diversity, but also how it has this tremendous influence on our brain, and our brain's behavior and function. So regarding the nervous system, I think this is one of the key things that I'm going to be focusing on today. This is one of the main pathways. So I just want to review some of the basic anatomy of our immune system and connect it to this gut-brain axis. So our nervous system has two major divisions: the central nervous system, which is comprised of the brain and the spine, and then the peripheral nervous system. And this peripheral nervous system is divided into four parts. First, the somatic, which is the part of our nervous system that we use when we voluntarily and consciously do anything like walk, talk, wave our arms, look up, look down. And then the rest of this peripheral nervous system is made up of our autonomic nervous system, which is comprised of the sympathetic nervous system, also known as fight or flight, the parasympathetic nervous system, which is responsible for promoting that state of rest. It supports digestion. I always like to refer to this also as where repair and healing takes place, because this is a state of, like optimal digestion as well as a reduction of inflammation. I also kind of like to think of the parasympathetic nervous system as the part of our nervous system where life is good and where we feel good and where our body feels really regulated. And this can oftentimes, translate into how we respond to stress and just what our stress resilience might be, and how this is really connected to an integral for that healthy gut-brain axis. And then there's the enteric nervous system, and we're going to talk a lot about the enteric nervous system today. But this is what's known as the second brain. And this is a very complex network of neurons that reside within the walls of our GI tract that are, again, communicating to our brain. And so in order to achieve optimal gut-brain health, all four parts of the peripheral nervous system have to be in balance, they have to be operative, and they have to be communicating with one another as well as with the central nervous system. So I want to first talk about the vagus nerve, because this is one of the keys for the communication of the gut-brain axis. The vagus nerve is one of 12 cranial nerves in the body and is a key nerve that is involved that is a part of the parasympathetic nervous system, that rest and digest and repair part of our nervous system. In Latin, vagus means wandering, which is really appropriate when we consider that it's the longest cranial nerve and that it wanders down from the medulla oblongata, which is located in our brain stem, down the spinal cord, where it then branches out and innervates the entire digestive system, and starting with the backs of our throat, down to and into our esophagus. It attaches to our stomach, to our small intestine, to the large intestine, the pancreas, the liver, the gallbladder, our kidney, our spleen, all the way down to our colon. And it is also the part of our nervous system that connects that our brains to our heart, our lungs, and our other organs. So you can see how important this nerve is in the gut-brain connection. So there's some research that indicates that about 80% of the information in the vagus nerve is actually coming from the organs. So things travel from the gut, from our heart, from our lungs, and back up to the brain, and tells our brain what's going on in our body. These are the signals that are referred to as afferent. And then the signals that communicate from the brain down to the organs are the efferent communication. So it's interesting, I think, to think about the fact that 20% of the information exchange is efferent signals from the brain to our organs. And again, the way that I think that this is so fascinating is that, again, when we think about the microbiota that live within our gut, depending on what that picture of microbial diversity is, there can be like really different information that's going back up to our brain, and how this connects to everything that is happening with our heart rate, our respiration rate, again, how we respond to life, how we respond to stress, how well our digestion is working. So it's, to me, it's a really fascinating part of this whole gut-brain communication. The other thing that I think is interesting is that microbes that are in the gut use this vagus nerve to communicate to the brain. And you can, again, imagine, like, just depending on what the microbes are, just what different types of communication there is. So here's just kind of a quick summary of the role of the vagus nerve and how it's involved with everything from digestion, heart rate, immune function, breathing, inflammation, and stress response. So again, kind of in this deep dive of the nervous system, I want to spend a little bit of time talking about the enteric nervous system, which is one of the components of the gut-brain axis, and is part of our peripheral nervous system. So oftentimes, the enteric nervous system is referred to as our second brain, because second to our actual brain, it contains the most neurons in our entire body. There are actually more than 100 million nerve cells in the human intestine, and a number of these nerve cells are equal to that of our spinal cords. So when you add on the nerve cells of the esophagus, the stomach, and the large intestine, you find that we have more nerve cells in our gut than our entire spine. And in fact, we have more nerve cells in our gut than in the entire peripheral nervous system. So this is a vast nervous system that produces a lot of, I like to call it like a chemical warehouse, where it produces every single class of neurotransmitters that are found in the brain. The importance of the enteric nervous system in the gut-brain axis is that it's responsible for controlling and regulating various GI functions, including digestion, absorption, motility, secretion, and blood flow. And the other thing that's fascinating about it is that it operates autonomously, meaning that it can function and carry out tasks without any input from the brain or from the spinal cord. It's connected to our central nervous system through the vagus nerve, and again, allows that bidirectional communication. If you're interested in learning more about the second brain, this is a book that I absolutely love. I read it probably 5 years ago, but I recently just listened to a presentation by Dr. Michael Gershon. He's a professor of pathology and cell biology at Columbia, and is known as the father of neurogastroenterology. So anything that you can like listen to online, or if you're interested in learning more, this book is really fantastic, going really deep diving into the enteric nervous system. So one of my favorite parts about the research of the enteric nervous system is how science is not only able to explain the pragmatics of the enteric nervous system, but it's also how there's this kind of emerging research that shows us that the enteric nervous system is also responsible for certain feeling states and intuitive decision making. So when you think about, I don't know, encountering danger, or if you're you meet somebody and you just kind of have a bad feeling about them, that's actually the microbes that are within your gut that are communicating to your brain, that are telling you that, like that give you that gut instinct or that gut feeling about somebody. So again, another example of just how how these microbes are, really, they're just in charge of everything within our body. So I want to talk a little bit about what impacts the microbiome and the gut-brain axis. So there's this idea that our environment and what's going on inside our internal and our external lives and disease is all connected and impacts the body as well as the gut-brain axis. The word that I like to use to encapsulate that is the exposome. It's a brilliant word that I first heard by one of my mentors, Dr. Aviva Ram, and it sounds like exactly what it is. It's really the world that you're exposed to. Exposome science is something that explores how everything that we're exposed to in our external and internal world influences our health, our symptoms, syndromes, and disease. And, I think that this could not be truer when we're considering the exposome on the microbiome and that gut microbiome brain axis. So again, we've kind of talked about things that influence the microbiome, things like nutrition and diet, things like alcohol, but I also, just want to mention things like environmental toxins and their impact on disrupting the gut microbiome and how it contributes to inflammation and how that can have a really negative impact on the gut-brain axis. But also things like chronic diseases that we live with, they like, again, this kind of circular communication that happens is that, that inflammation can also alter the microbiome. And once that microbiome is altered, it can negatively impact that disease state. And again, becomes this kind of circular round and round. The other thing is, and there's a lot of different things we could talk about with this, but I just want to mention another, component of the exposome, which is lack of social connection, and how that's been associated with alterations in the microbiome, including inflammation, and that it can contribute to, we see this as a contributor to various GI as well as neurological diseases. And there was a study actually that I was reading preparing for this that was talking about people who attended church one time per month as having a lower level of chronic disease than people who don't. So I'm going to kind of skip ahead here just in the sake of time. And okay, so the other thing, one more thing before we kind of move on from all the physiology around the gut-brain axis and the nervous system is I just want to mention the role of short-chain fatty acids, especially because of the importance of, for us as dietitians, and how diet is one of the things that can really alter the amount of short-chain fatty acids that are available in the gut. So, and short-chain fatty acids, the ones that we're talking about are acetate, propionate, and butyrate, and these are the main metabolites that are produced in the colon by bacterial fermentation of dietary fibers and resistant starch. So in addition to the long known role of the colon and energy supply and even like tropic factors, there's great evidence that supports the idea that short chain fatty acids exert these crucial physiological effects on organs, including the brain and the gut. And we see this with the influence of short chain fatty acids on hormone production like TYY, GLP-1, GABA, 5-HT, but they also influence inflammation. And this is why consuming a high fiber diet is something that's protective against colon cancer. Short chain fatty acids are also known to influence the enteroendocrine signaling as well as serotonin secretion. And so again, that's all connected to things like the HPAT axis. And then, like, kind of like bigger picture, as it's impacting all of these different systems in our body, we also see that, short chain fatty acids ultimately can influence things like appetite, gut motility, energy expenditure, in addition to colonic health. So short chain fatty acids and, focusing on this as dietitians is a way to support and encourage people to change their diets, so that they, consume more fiber and resistant starch is, I think, one of the important roles that we have. Okay, so let's talk a little bit about the negative impacts on the things that are negative impacts on the gut brain axis. And the first one, and probably the most important one, and I see this in my clinical practice all of the time, and I'm sure anybody else that that works with patients, but also works in this space of gut health, sees the impact of stress on symptomology of GI related conditions, but also on things like anxiety and depression, inflammation in the body. So I think it's important to remember though that not all stress is bad. And if you've ever read any of the research by Kelly McGonigal, she has I think a really interesting spin on this. She has one of the most watched YouTube, I think it's a TEDx talk called "How to Make Stress Your Friend." I often will refer my patients to that TEDx talk because when you understand that stress is really a survival mechanism and that is designed to be there and alert us to danger, we can change our perspective around it and kind of create some separation and distance between the stress stimulus and how we respond to it. And this kind of like promotion of awareness around stress in our lives and what's stressing us out and how we're responding and not reacting to it can really influence and modulate the gut brain axis. So when we're talking about the type of stress that disrupts our gut brain axis as well as our health, it's really this chronic unremitting stress that I think most of our patients are living in daily. The other thing that I like to kind of throw into this category of stress is trauma. And this can be, big T trauma, little t trauma, historical trauma. And again, I think in clinical practice, we see this a lot, how the impact of, trauma on physiology, on, genetic expression, and how that influences disease, and particularly diseases of the GI tract is, really profound. Um, so how this is all connected, again, just, to kind of like bring some of these concepts full circle, is that when we're under stress, it activates our autonomic nervous system or that fight or flight response. And when blood is shunted to our extremities, to our heart and our brain, it causes the release of catecholamines, which then increase cortisol, which then recruit the immune system and create inflammation, and it's the same inflammation that causes disease. So this is the type of stress that impacts our vagus nerve, and there's studies that show that when our vagus nerve is damaged, which can happen in the case of traumatic brain injuries, if people get hit in the stomach, if they're in a car accident and experience whiplash, if they have injuries to their spinal cord, can actually disable this HPA axis response in a way that is healthy and able to really, kind of, like I said, like interrupt that stress cycle. So, and I think this is like, again, such interesting research to me is that when it comes to stress, there's like a set point that we have for our, they call it the stress axis set point, that's established at birth. And a lot of this has to do with what evolves and what changes with our microbiome, during the birthing process. This stress And, gut-brain axis set point is also something that's influenced by how we're fed when we're babies. So breastfeeding, versus whether we're fed by formula, um, and um, I think like with breast milk versus formula, a lot of that has to do with that immune modulation. And again, just how that's changing the bacteria that are within our gut. I'm going to just kind of move on here for the sake of time. So this is I just want to again like take a minute to point out the impact of stress and cortisol on the gut, because I feel like this is something that just doesn't really get talked about enough. This which is that as cortisol increases, it actually gets pumped into our gut, and inside the gut, the cortisol is then metabolized by microbes, and then the byproducts of that metabolism go to the kidneys and increase sodium and potassium, which then increases blood pressure. Um, and then from there, as there's more blood that's being shunted to, again, the brain, into the heart, into our extremities, blood is shunted from the gut and causes our motility to slow down. Um, and then with the cortisol that's in our gut, it binds to the glucocorticoid receptors, which give a negative feedback signal, again, to slow the gut down. Then this excess cortisol in the gut reduces the gut's ability to produce mucus, which, again, is that, again, reducing the resiliency of the gut and leading to things like more intestinal permeability and leaky gut. This then increases inflammation. It can increase inflammatory markers like IL-6 that then go back to the brain and reactivate the hypothalamus, which then turns on a new cycle of stress and causes this whole cycle to start again. And so, and I think it's just so important to just realize that, again, for a lot of our patients, despite what they try to do, in terms of regulating stress and regulating their stress response, a lot of this is just being done within their body. It's kind of being done to them because this whole cycle is being turned on all the time. And so one of the ways that I think we can really help support our patients in this is to help heal their gut and, again, change that microbiome and give them, supportive information and, just how to regulate that gut-brain axis. So I like to think of this as like a single stressor that's in the morning, like a bad email can perpetuate the same stress response throughout the entire day. And it doesn't have to be that they keep seeing the email. It's just like this whole physiological stress response is happening throughout their body, which impairs parasympathetic nervous system function. And, and I think in our modern day society just doesn't really give our bodies a chance to ever turn this off. Okay, so I think just in the sake of time, I'm gonna move kind of quickly through these next few slides. So, and I told Carrie Ann this, I was like, I could probably talk about this forever. I love this topic so much. So forgive me for just barraging you with all of this information, but the other thing that I just want to, take a moment to point out is the impact of the microbiome and, dysbiotic bacteria on disease. And, whether it's, dysbiosis, whether that can create that metabolic endotoxemia, where the inside of the gut becomes toxic from the toxins that are produced by bacteria, the chronic inflammation that's produced by these bacteria. We're now starting to see that there's a connection between what's happening with the microbiota and the influence that it has on neurological disorders. And again, we're not going to deep dive into all of these today, but I just wanted to make sure that you were all aware of it. The other thing about the microbiome and the gut-brain axis is that it can also change our behavior. And this is one of my favorite studies, is that as a study that was done of 41 toddlers that looked at the number of species in the microbiota, and they found that less diversity in the microbiota was associated with sadness, with being less cuddly, with being less soothable. And it was particularly in children who had high levels of bacteroidetes, which when the bacteroidetes and firmicutes are out of balance, is a form of dysbiosis. The other thing that I find fascinating is that the microbes in our gut can really change our experience of pain, and can really change and kind of dysregulate the gut-brain axis that leads to visceral hypersensitivity, inflammation, and even an increase in pain disorders. And then this topic for me, the gut-brain axis and IBS, this is primarily the patient population that I work with. And I just love seeing what the new research is showing around IBS. I think in the 80s and 90s, IBS was really considered to be a psychoneurotic condition that was associated with stress. We didn't really have like any organicity to it, meaning we didn't understand what the physiology and what the underlying physiology was. People really just thought that it was like all in their head, this is, I think, really unfortunate, considering there's such a huge, section of the population that's affected by IBS, statistically about 40%, which is, just staggering to me. There's a lot of job security in this particular niche within the world of nutrition. And so what is interesting now is that we now know that IBS is no longer something that is just in people's head, but that rather that this is now being considered a disease that is a disorder of the gut-brain axis. And again, this is something I really see in clinical practice, and I'm sure many of you do too, is that it really can respond to targeted interventions of the microbiome, the gut-brain axis, and inflammation. So I'm just going to breeze through this because, again, we don't have a lot of time, but let's just talk about a few strategies that we can use that are very pragmatic in supporting the gut-brain axis. The first is vagus nerve support. So here's what I want you to be on the lookout for when you're working with people who have any neurological conditions, GI-related conditions. If you see some of these symptoms, I always want you to be thinking about this as a sign of just poor vagal nerve tone. And this oftentimes will prompt me to ask people whether or not they've ever had any of those any experiences where they've maybe had, a lot of stress, trauma, traumatic brain injuries, concussions, if they've ever been, like hit in the stomach, if they've ever had, even surgery, like abdominal surgery, and even like just any surgical interventions can sever the vagus nerve and impact that communication between the gut and the brain. So in 2005, the FDA approved vagus nerve support for people who had treatment-resistant depression. And at that time, it included stimulating the vagus nerve with electrical shocks, which can appear to change the brain wave patterns and help to reduce and eliminate signs of depression. But there's much easier things that we can support our patients with, and including ourselves in doing. So some of the things, and again, remember our vagus nerve is part of our parasympathetic nervous system. So any intervention that we do that supports parasympathetic tone is going to be supportive of vagal nerve tone. So things like diaphragmatic breathing, meditation, exercise, and also through that, modulation of the gut microbiome. Laughter is a great one. We can use probiotics, social connection. There's even some cutaneous vagal nerve support devices that are out on the market now, things that you can kind of connect to your neck and will actually stimulate the vagus nerve that can help with that signaling and transmission. Biofeedback is a great one. Yoga, gargling, ice baths, singing. So there's lots of things that we can, support our patients in doing. And then, of course, there's a lot that we can do in the realm of food, in encouraging and educating our patients on the types of foods that have that positive impact and help, support growth, diversity, and proliferation of the gut microbiota. And again, I know you guys are all dietitians. You've probably seen a lot of this information already, so I'm just going to kind of breeze through it. So we have a few minutes for questions at the end. And then this idea that symbiotics and this is something that we can do both through food, using prebiotic and probiotic rich foods, as well as using supplements that contain pre and probiotics that create symbiotics, which are again, one of the evidence-based ways of growing our microbiome. And again, I don't have a ton of time to talk about this, but I just want to touch on the concept of psychobiotics, and particularly this one that has been just kind of hitting a lot of the literature lately, which is Bifidobacterium longum 1714. So this is a bacteria that people who have a really balanced mood tend to have a lot of in their microbiota. These people, interestingly, are usually pretty good sleepers. And so just again, kind of, I think, really indicating just how this bacteria helps with regulation of the nervous system. So what makes this bacteria so unique is that it contains a carbohydrate called an exopolysaccharide, and about 99% of all other bacteria in the microbiota do not have this. And what makes this so amazing is that it prevents cortisol from making the gut leaky. So if you think back to that whole cortisol, cycle that people get stuck in, this is one of the psychobiotics that can actually interrupt that whole process. So these unique carbohydrates are part of brain development in utero, and the function of the brain is pivotal in our exposure to this in utero. So this Bifidobacterium longum, it will bind to the receptor on the lining of the gut and send a neurotransmitter to the vagus nerve that then changes the brain function and the brain wave into a theta brain wave or a flow state. And this is that same flow state that people get into when they're meditating, and it's this flow state that people are in when they're feeling really calm. And so when people have more of this particular probiotic and bacteria in their gut, it really can change just how they react and respond to stress. So I know that I'm out of time, so I'm going to just open it up for a few questions, and I don't know